Hello, welcome. Today's video we are talking about range and domain of a function. I wrote part 2 here. There's a previous video. If you have not watched it, please go through the channel, subscribe to this channel, click on the notification bell, and then search for range and domain of a function part 1. Go through it for basic explanation and range and domain, and then come back to watch this one, since in this video we are solving one or just two examples of questions under this topic, and I hope by the end of the day we will get the understanding we want. So in this video, whatever we have here, we have J is to x mapping to 1 out of 3x, and we are told to find the range and then the domain. So in the previous video, first let's talk about the domain. We learned that the domain is the possible values of J of x, or the point of J of x that will make the equation defined, or this equation defined. And I was saying that, in simply put, we are saying that we have certain values for x that when we substitute into x, this equation can be solved or will be solvable. And there are a certain value that when we substitute into this equation will become or would be undefined. So the possible values that will make the equation defined or will help us to be able to solve this are many values, and these values we cannot write all of them. So all we need to do is to find that value that will make the equation undefined. Then we can use it to write a statement to get other values that will make the equation defined. And to do this, we start by changing this into an equation by saying we have J of x, the function J of x equals 1 out of 3x plus 1. The first step is to write this, change this into an equation, and then the next thing we need to do is to write our statement. Since we want the equation to be defined, we want the values that will make the equation defined, we can write a simple statement by saying for J of x to be defined, the denominator must not be equal to 0. So 3x plus 1 must not be equal to 0. So 3x plus 1 must not be equal to 0. Sometimes in our basic schools, we equated 3x plus 1 is equal to 0. Then we come back and write another statement. Once we are able to find the value of x, we come back to write other statement by saying, but x must not be equal to 0. But in this video, we want to write the statement straightforward, because if the denominator is equal to 0, the equation will be undefined. That is why we are using 3x plus 1 must not be equal to 0, so that we can find the values that will make the equation defined. So I will solve for x. We always solve for x. Then we say 3x must not be equal to minus 1. My 1 going here. And then x must not be equal to minus 1 out of 3. So it is minus 1 out of 3 that when we fix here, to make the equation undefined. Let's test and see. This is just a rough work, so don't write this. So once we test, we can say 1, 3 into bracket minus 1 out of 3, replacing minus 1 out of 3 with x plus 1. This will take care of this, and then we have 1 out of minus 1 plus 1. So this will give us 1 out of 0, which makes the equation undefined. This is not 0. Even when you punch this on the calculator, you will get error. So now it is this value that makes the equation undefined. This means any other value apart from minus 1 out of 3 will make the equation defined. So let's write that statement. So now we can write the domain statement by saying, therefore, the domain of g, of the function given to us is g, equals, now we write a curly bracket. This is not a square bracket. We have other brackets, but it is this type of bracket we use. We write our statement by saying x is such that x here is such that x a member or belongs to all real numbers. This is the sign for all real numbers. X must not be equal to minus 1 out of 3. So I can close my bracket, and this is our what? Domain. So this simply means that if minus 1 out of 3 will make the equation undefined, then any other value apart from this will make the equation defined. But those values are many, so we cannot use them. So now, let's go to the range. How do we find the range? In the previous video, if you have finished watching, we discussed that the range are the output values of the function g of x. They are also called the y values, and these are the values that the function g of x can take. What do I mean by that? To be able to find the input of any input of x will give us a range depending on the equation given to us. So to find the range, all we need to do is to equate the function given to us to y by saying let y be equal to the function g of x given to us. We know g of x to be 1 out of 3x plus 1, so therefore y will be equal to 1 out of 3x plus 1. The next thing is to find the inverse of what? Y, of the equation y, and to do that we can cross multiply or multiply 3 by 3x plus 1 to make the equation linear. So when I cross multiply here, I will get y into bracket 3x plus 1 equals to 1, and we expand the bracket or open bracket by getting 3x y plus this y equals to 1. Now, to be able to find the inverse, we need to make x the subject, and to make x the subject, I will just have to carry this to the other side. Those of us that have basic problems in maths, I'm just doing this for our sake. So we have 3xy equals 1 minus y. So x will be equal to 1 minus y out of 3y. So I have divided through by 3y, and I've divided through by 3y. So this 3y will cancel 3y here to make x the subject. Now that we have been able to make x the subject, x here means the inverse of what? Y. Now let's look at this diagram. If we have this diagram, this is the function g, this is the inverse function g inverse. This is x, this is y. So what this diagram means is that g of x equals to y. G into x will give us what? Y. That is why we said let y be equal to g of x. And then g inverse of y will be equal to x. That is why we are saying x is equal to what? The inverse of this equation. Why we are saying x here is the inverse. So therefore we can say that, looking at this diagram, we can say that x equals g inverse of what? Y. Now it is this that we need. That is why I explained this diagram. Those of us that have come across this, we already know, but if you haven't come across this, then that is what it means. X here equals g inverse of what? Y. Now let's go back. You do not need to use the diagram to prove to your examiner that x is the inverse. So from here we know that x is the inverse of what? Y. So we write that statement by saying therefore g inverse of y equals whatever we got, 1 minus y out of 3y. So now this is where we continue from. So g inverse of y equals 1 minus 3y. Now we need to check the denominator and then repeat the same step we did for the domain. So now all you need to do is to ask yourself, if this 3y equal to 0, the equation will be undefined. We are talking about the denominator. And so if 3y is not equal to y, then we can get the values of y that will make the equation define. So now we will say that for, we repeat the same step by saying for G inverse of y to be defined, write this statement, the denominator 3y must not be equal to 0. That is, y must not be equal to what? 0. So all we are saying from this step, we find the inverse of y. The inverse of y, to be able to do that, we just cross multiply and make x the subject. Once we are able to make x the subject, x stands for the inverse. In your next step, you state for him that x itself is not the inverse. X is standing for the inverse. So you write this, then the function given to you was g. So the function g inverse of y equals 1 minus y out of 3y. Don't forget that we are working in terms of what? Y equals 1 out of 3x plus 1. That is why we have y here. We are working for y values. So now that you have written that, which is the same as 1 minus y out of 3y, the next step is to find the values that will make it define. And these values, to do that, the denominator must not be equal to 0. So for g inverse of y to be defined, 3y must not be equal to 0. That is the same as, if I make y the subject, then I'll get y must not be equal to what? 0. And that is it. So we just write the range. The final answer is range of g of x equals, now at the beginning we said that let y be equal to g of x, so I'm bringing it back. I do not need to, y must not be equal to 0, so g of x must not be equal to 0. So now I'll say that g of x, this time I didn't use x but g of x, because y equals g of x. G of x is such that g of x belongs to all real numbers. This is the symbol for real numbers. G of x must not be equal to what? 0. I don't want you to be confused and tell me, or ask yourself, why is it that y is equal to 0 and I'm writing g of x? That is why I am coming back again. I told you that y here must be equal to g of x, so we are bringing it back. That is why we have this. And always remember, at the final answer, it is g of x you use to. This is what we are looking for. The values of g of the values of y that g of x can take. That is what we are looking for. So this is the range. So this is how we go about it. Let's take another example and see what we can do. Let's say we have been given an equation as in h is to x mapping to 4 out of 4 plus x, and then we need to find the range and the domain. We already know what we have to do, so for domain, we say for the function. So the first thing we need to do is to write the equation h of x equals 4 out of 4 plus x, and now we write our statement for h of x to be defined. The denominator 4 plus x must not be equal to 0. I repeat, always 4 plus x must not be equal to 0. 4 plus x must not be equal to 0. Making x the subject means we have x must not be equal to minus 4. So now when we put minus 4 here, the whole equation will be undefined. So this means we have been able to look for the value that will make the equation undefined. Now this will help us to write the statement for the values that will make the equation what? Defined. So now we can say the domain of H equals x is such that x belongs to all real numbers. X must not be equal to minus 4. So we close our curly bracket. Now we move on to the range, and to find the range, we know how we do it. We equate the function given to us to to y, and then we find the inverse. Write the statement for the inverse. Repeat the same steps here, and we are done. So for range, let let h of x be equal to y. So we have 4 out of 4 plus x equals to y. We can do cross multiply here. Okay. Then we have 4 equals y into bracket 4 plus x. We have 4. I can turn it. I can choose to bring this here and take this one to the other side. Because I wrote h of x first, that is why I brought the function there. So don't be confused. So 4 equals 4y plus xy. We want to make x the subject. So I'll pick this one to this side by getting 4 minus. I'm trying to avoid negative. Some of you will bring this one here to get negative xy, and then take this one here to get 4y minus 4. Then when you finish, you divide through by negative. Fine, you will still get the same answer, but try to avoid negatives, so that if you miss any of the negatives that you don't cancel, you get the work wrong. So that is why I'm trying to avoid negatives. So to give me 4y equals xy, and then I can repeat this step by saying xy equals 4 minus 4y, which is still the same thing. So now I need to make x the subject. To make x the subject, I just need to divide by y, divide through by y, so I can cancel this one. So I'm going straight for it. I'll just get x equals 4 minus 4y out of y. Now this x becomes the inverse, and we learned in the first example that the inverse is x. We rewrite the inverse by using the inverse statement. So the function given to us is h of x. So I'll just say h inverse of what? Y, because we are working for y values. So h inverse of y equals 4 minus 4y out of y. So now we can write the statement if y equals to 0 the equation will be undefined. So I don't need to solve. All I need to do is to write for h inverse of y to be defined. The denominator must not be equal to 0. Y must not be equal to 0. Any other value apart from 0 will make the equation defined. If I fix 1 here, then I'll get 4 minus 4 into bracket 1 out of what? 1. And the final answer I will get is 0, which is correct. But if I fix 0 here, the whole equation will be incomplete. We can't solve, and it will make it undefined. So any other value apart from 0. So therefore, we can say that the range of the function given to us is what? H of x. This time I didn't say h, but I said h of x equals, we also know that y equals what? H of x from here. So I'll bring it back. H of x is such that h of x belonging to all real numbers, h of x must not be equal to 0. And so this is our range. So that's the two examples that we have. In our next video, we'll talk about the multiplication, we'll talk about multiplication of functions, this kind of functions, composite functions. Let me put. So subscribe to this channel and wait for more videos. Thank you.